This is an overview of the Texas STAAR Grade 8 Mathematics formula chart to reference materials in preparation for geometry students taking the 8th grade STAAR. It's been a while since you've had some of this stuff, so let's make sure you remember everything that's on the chart. This is what the chart's going to look like that you're given. Okay, you'll have slope-intercept form. You're all proud graduates of Algebra 1. You know what that is. M is always slope, B is y-intercept. Direct variation. Now, you had direct variation last year, but let's make sure that you're remembering it's just slope-intercept form where the intercept is 0. And I use K, the letter K, instead of the letter M for the equivalent of the slope. It's the constant of variation. K is the constant that you're multiplying by. Now, we used a lot of that when we were doing our geometry dilations. You multiply it by it. You remember that direct variation always goes through the origin, which is what makes it proportional. Well, I mean, it is proportional. Passing through 0. So when the y-intercept is 0, it's proportional. That's a big thing in 8th grade. It's been a while since you've had it. Remember it. If it says that it is direct variation, that means that you can form a proportion with the coordinates of the points. We did that when we were doing our geometry dilations. It's the same deal. We just didn't call it that way. Slope of a line, I'm thinking you know that. Okay, don't think that you know it so good that you don't make yourself slow down and do it right. I strongly recommend that when you're calculating slope, you actually write 2 by one of the points and 1 by one of the points. And rehearse in your head and make yourself say the y value from point 2, the y value from point 1. Because otherwise you're going to switch them and make a careless mistake. Okay, some of the other formulas on this chart. In general, not every time, but in general, a capital letter is going to mean something that could be that's usually calculated, and a lowercase letter is going to mean something that's usually measured, like with a ruler. That's like a line segment. Okay. So here, C is for circumference. C is for circumference. And it's 2 pi r or pi d. We'll have a whole lot more of that in geometry than we ever would have had in 8th grade, but life being what it is this year, everything's just out of order. So, when you're going to use pi, use the pi button or use 3.14. The test may tell you which one to use, and if it does, use the one that it tells you. If you use one and your answer gets off by just a little bit, try the other to make sure if that's the right one. Don't just say that's close enough, because you may have made a mistake. So go back and double check on it. Okay, the area of a triangle, half a base times height. Again here, capital A is going to mean area. Okay? The area, capital A, something that's generally calculated. Although not all the time, sometimes you're given it. Then what we've got here is what you're used to, which is base times height, half of base times height. Remember the thing that you're going to make a mistake on, and we talked about this when we did altitudes, when we did our triangles. The height must be perpendicular. Don't let it sucker you into using a slant height, the side of a triangle. The height has to be perpendicular. Now, rectangles and parallelograms. Typically, when we think of rectangles, we're going to say area, capital A, equals length times width. Well, length is the same thing as base, and width is the same thing as height, and it doesn't matter which one you call it. You can say length is either base or height, and then you can say width is the other one. It's a rectangle. It doesn't matter. So don't worry about it. And don't be bothered that it says base times height instead of length times width. It means the same thing. For a parallelogram, however, Remember that height is always perpendicular. So when you have a parallelogram, the side length is not the height. It's going to always be the perpendicular distance between the parallel bases. Okay? So in the case of a parallelogram, it'll matter which one you're calling the base and which one you're calling the height. And you can do it either direction, doesn't matter. But the one that you're calling the base will be two that are parallel. Of course, the others are parallel too. And the perpendicular distance between the two parallel bases is the height. That's no different than what we've had all along, just to remind you of it. Trapezoid, we've had. Make sure you remember it. A reminder on this one. The two bases are always the parallel lines. It doesn't matter if there's all of these. The base, it doesn't matter if it's to bottom. This is a math term. It doesn't mean bottom. It means base. The two parallel ones are the one that you average. So the two parallel ones, add them and take half. And then multiply by the height. Again, perpendicular. Area of a circle is pi r squared. R is radius. Area is capital A. Pi, again, either the pi button or 3.14. If it's off by just a little bit, again, find out why. You may have made a mistake. All right. Here we've got surface area of prisms. Y'all have not had a whole lot of this at all, so I'm going to mention it really quickly. When we do our geometry units, which one or two of them will get done before this test, but you need to know this to be able to do well on the test. It looks at it in a certain way, and you need to be aware of the perspective of this formula chart to be able to use it properly. They talk about the lateral surface area and the total surface area of a prism. Now, for a rectangular prism, I'm not going to ever do it this way myself. I will unwrap it, lay it down, and do them separately. But since you've got the formula, let's look at how it works. Here I have a rectangular prism. In other words, a box. Okay? What it's talking about, lateral, is the area, the distance around. Oh, let me start with the can. That'll be more obvious. Okay? So the lateral surface area, one way I try to remember which one's which, lateral is like label. So here's the dog's no salt beets. Oh, they like beets. Okay? The lateral surface area is where the label goes. Lateral, label. Lateral, label. So here we take the label off, and we notice, as you're already aware, that when we unwrap the label, it'll always be a rectangle. So for a cylinder, which is one here, it's going to be, this is the lateral surface area. Okay? It's just a rectangle. It's just length times width, or base times height, which I'll show you some more here in a minute. Okay? Now back to my box. The lateral surface area, where did I put it? Oh, here. The lateral surface area, imagine I'm wrapping a label around my box. Okay? I wrapped the label around. When I unwrap it, it's a rectangle. So, notice, okay, so I'm going to call this the lateral surface area. The two ends will be the bases of the box, of the prism. So, that's going to be like a big B, because it's not just a line segment. All right, so I've wrapped the label around. Notice that when I wrap it around, that it is the perimeter of the base. When I wrap around the label, the distance that it goes is the same as the perimeter of the base. Okay? So one more time. Here's my prism, my rectangular prism, a box. I wrap a label around it, and I notice that the distance that the label went around my box is the same as the distance around the base, or the other end I'm not wrapping. In other words, it's the perimeter of the big B base. So it's the same. Here's my big B base, and I walk it along, and I can see that the perimeter, the distance around my base, is the same as the length of the rectangle that is the label. Then the width of the rectangle is the same as the height of the box. And I'm setting the box like this. Okay. This is the width of the rectangle. It's the same as the height of the box. So I unwrap it, and I have a rectangle that has the perimeter of the base as its length, and the height is the height of the prism. Again, always between the two bases. Height is always between the bases, and it's always perpendicular. Okay, so the height or width of the rectangle. The width of the rectangle is the same as the height of the box. The perimeter of the base of the box is the same as the length of the rectangle, or base times height. But that's a little b times a little a. See, I don't like how they use these little b's and big B's. So see, this is a little b base. And the square itself, rectangle itself, is a big B base. Okay, so you got to, you see, if you're not used to that, they're going to catch you on that. So that's the prism right here. And it tells us that the lateral surface area is the perimeter of the base times the height of the structure. And we see that that works. We also need to see here that the total, okay, if you're wrapping a present, if you have a present in here, I've got my ink in this one, which is too expensive. So if I want to wrap it up all pretty, oh look, that's not a very good wrapping. I got to cover the ends. I have to cover the box totally. Okay? Totally. What just happened? I just flipped. Okay, I've got to cover the box totally. I'm sorry, there must have just been a blip. I'll have to kind of, okay. I've got to cover the box totally. So I have the lateral or label. And to wrap it up all pretty, I also need to cover the bases. So for a rectangular prism, that'll be one big label and two bases. Okay, there's different ways you could arrange these that would work. Okay, so that's total surface area covering the whole box. This is the area of the label. Surface, big S, is lateral surface area, is surface area. Big S is surface area. And you have two kinds of them, lateral and total. Okay? Lateral is just the label, and total is the whole thing, the label plus the two ends. Okay, for another weird shaped one, to show that it works for all of them, which is really why they use that formula. They want one that works for everything, and that doesn't. That's a good thing to do. Say you've got some HEB whipping cream here, and you want to wrap that up. Well, what's lateral and what's a base? Okay, let's remember that the base are always the two that are perpendicular and parallel. They are perpendicular for this, they're not for geometry. The two faces that are opposite each other and parallel. So this is going to be the base. This is a pentagon, and we name it by the base. So this is a pentagonal prism. because the two bases that are opposite each other and parallel, and they're pentagons. So these are the bases. So then the label, we're going to wrap it around this way, because you're going to wrap the label around the bases. And it looks kind of weird doing it this way, because I would have said the label the other way, because that's where HEB put the label, right? Or put the information. But there's information all around. So this then is the lateral surface area, because the lateral surface area, or the label, is always between the bases. Okay? The bases are the same size and shape, they're congruent, and they're parallel and opposite each other. So in this particular case, this is the label, or the lateral surface area of the whipping cream box, and these are the two bases. They would fit here kind of like this. No, like this. Okay? Yeah. Or over here. Or you could also put them here like this. By the way, this is called a map. It's kind of like you unwrap it and fold it out. I personally figure all my surface area by unwrapping it and figuring the individual ones. However, the formula is handy, and it is on your formula chart. So if you're going to have it and use it, you need to know how to use it. Okay, for volume, I'm going to ask you to look at the geometry video a little bit early on that, so you'll have that. I'll post it for you. We'll have the volume of the different shapes. Again, volume now is going to be a capital V, something that's usually calculated. Watch the video on why this is what it is. For a cylinder, the more commonly used one, for a prism, you can also use, for a rectangular prism, you can use length times width times height, which is what you've always used, and you'll get the same result. When you watch the video, it'll tell you that. For a cylinder, it's pi r squared h. If you already know that one, it works just fine. This is the general formula, and it's the one that's on the sheet. Pyramids and cones and spheres, I'll talk about in the video that you're going to watch separately. Okay, down here, if you don't know the Pythagorean Theorem, I'm sorry. By this point, yeah, I'm sure you know the Pythagorean Theorem. But let's look right here. You know how I said capital letters are things that you calculated usually, and little letters are things that you measured in a line usually? Well, not true here. Okay? This is the banker's way to do it. And we use the banker's terminology. Capital I for interest, capital P for principal. There's also a video on this. That means the amount of money that you start with. I is for interest, which is money that you earn on money. Watch the video. Rate is always a decimal. Not as a percent. You're usually given it as a percent, and you need to convert it. The P is principal. It's not percent. R is the one that goes for the percent of interest. This will always be annual by the year for simple interest. Compound interest can be for any period of time, but you have to be consistent. If you use days for one part of it, you've got to use days for all of it. Again, here P is principal. However, A here is not area, it is amount. And it's the total amount. R is the rate, given as a decimal. T is the time in any units. Doesn't matter what the units are. For simple interest, the units need to be years. Compound interest, this is the same thing you learned last year in algebra as exponential growth. It's the same thing. You'll see that on the video. I just want to let you know that this terminology, the bottom two ones, are what they use for the banks. And we use their language so you'll know their language. Okay, so that's a little bit of help with the formula. So hopefully that'll be good for you.